Hello, welcome everyone. I am David Sanchez Wells from University of Sevilla, and this is my conference where I will talk about a systematic literature review on the genetic algorithms and their use in last-mile logistics using drones. First, I would like to give thanks to the organization of this Congress, which is NODOS DEL CONOCIMIENTO 2023. In this case, this is the 4th International Continuing Education Congress, and the main topic for this Congress is the innovation, research, and transfer in the age of artificial intelligence. As this video is being recorded previously in my place and not in live, then you will see it on the days 23rd or 24th of November of 2023. I am part of University of Sevilla, as said before, and the co-authors of these papers are my PhD directors, Pedro Luis González Rodríguez and José Luis Andrade Pineda. In this case, while Pedro Luis is part of the Department of Industrial Engineering and Management Science, José Luis is an expert and he works in the Department of Robotics, Vision and Control. Okay, so let's start with the conference. First, I would like to give an introduction about the revolution of drone-based last-mile logistics. First, I want to define what is last-mile logistics. In this case, last-mile logistics is the concept where of the last, we could say, is the last step in the logistics chain. So we are talking about the packages, the deliveries that have place to the final customer. This could be an individual, a particular person. This could be a company also, but we are talking about this last step in the logistics process. The case is that last-mile logistics is one of the most difficult problems to address, as usually this must have place in a very competitive environment with a huge amount of different variables that may make this process quite inefficient. So the research about this topic is one of the, is cutting edge right now. So this is the problem that we are addressing. And in this case, our approach, our research is based in the inclusion of drones in this process of last mile delivery, following what we will see now. Okay, so why do we want to use drones for last mile logistics? Well, first we have to say that the use of drones in last mile logistics is promising to enhance the efficiency and to mitigate environmental impacts, usually and quite closely related to last mile logistics. It would also reduce the operational cost, indeed. But yes, this is just one more aspect. No? But it's obvious that if we are delivering in less time, we are also pointing to be more sustainable and to reduce cost, always. That's sustainability in the long term, actually. And as said before, last mile logistics remains a complex challenge. When it comes to route optimization, in this case, we are including a new type of vehicles, which is drones. So this makes things much more tricky. In this world of the route optimization for last mile logistics, we are addressing the use of genetic algorithms. Genetic algorithms are a type of algorithm that have emerged as a powerful computational technique for solving complex optimization problems. And their application is quite promising today. So we decided to perform a literature review. In this case, it's a systematic literature review, to critically analyze the existing research on the application of genetic algorithms on route optimization for problems involving last mile logistics using drones. And after this systematic literature review, we will analyze these works that we find to draw some conclusions. In the next slide, I wanted to talk about the methodology that we have followed. In this case, as said before, we are performing a systematic literature review, but we used a specific approach. First, I would like to locate where we are talking about, the context of this research. And you can see in the figure 1, the literature review context. So going from the bigger to the smaller circle, inside the field of transportation and logistics, we can find the field of last mile delivery. As one particular case, we could talk about last mile delivery using drones, and our current focus is in the use of genetic algorithms for last mile delivery using drones. This said, we wanted to conduct this systematic literature review using Scopus as the main source of information for us. So we conducted a search in the Scopus database using the three indicated key terms. In this case, these are drone, last mile, and genetic algorithm. This search yielded a total of 14 different papers, from which only 11 were actually using genetic algorithms. So these papers were selected and used to perform our analysis. In this analysis, we looked to identify specifically 5 different topics: what problem was being addressed, what heuristic methods they were using, what types of vehicles were being involved, the number of different customers that were considered, and also the limitations and knowledge in these research papers. Then, after categorizing the research papers using these parameters, we also performed a detailed analysis to distill key insights. This is the result of the analysis for looking for the problem formulations. But first, let's look at table 1. As you can see, this is a table that synthesizes all the considered parameters that we were talking about before in a single view. So we have 11 references, and for each of these references, we have identified what problem they were addressing, what heuristics were being used, what other vehicles apart from drones were considered, how many drones were considered in each of these problems, and also how many customers were addressed in each of the cases. Okay, so we will go through this table one by one, but first, something that we can see in a first sight is that there is a very diverse problem formulations landscape. As you may see in the first column, addressed problem, we have CVRP, we have FLP, TSPD. So there's not a case, maybe we can find that TSPD appears 4 times, but this is the most common one. So actually there's quite a wide range of different problems that are being addressed. But we also found that classic formulations of problems, like the CVRP and the TSP, as mentioned, they actually appeared several times. So we also wanted to note that. We also identified interesting things, like that there are new innovative models, innovative problem formulations. In this case, we will be talking about the TDARP, which is for the track drone ATV, or we could be also talking about the EVRPD for the electronic vehicle routing problem with drones. What can we say, having this into account, that the research field is expanding beyond classical logistics models to address the unique challenges that using drone technology involves. So this is our first insight. Later on, we want to talk about logistics, about heuristics and operational aspects. When it comes to heuristics, well, as we were looking for genetic algorithm, obviously, pure genetic algorithms are the most commonly employed heuristic. This could be also not possible because maybe we could be talking about modifications or variations from the original genetic algorithm. But in this case, the state of the art is still using what we call pure genetic algorithms. As we can see, there is a very big contrast when it comes to consider the number of other vehicles apart from drones. But we found kind of a correlation. Usually, the use of multiple traditional vehicles is linked to problems that involve facility location and constraint satisfaction, while the use of single traditional vehicles is more predominantly used in TSP variants. And something that we can also find if we look at the column of drones is that most of the problems are actually addressing multiple drones. We also wanted to talk about the number of clients and the scalability of the problems. As we can find in the last column, sometimes we don't even know how many customers were being addressing the problem, which is an interesting insight. But we can also see that sometimes we talk about 10 clients, and in other occasions we are talking about almost 6,000 different clients. So there's a huge variety in the number of customers being addressed. What this is involving? Well, this is telling us that sometimes we are actually trying to address real scale problems in the size of a city, maybe the size of a province, but we are not talking about theoretical problems anymore. This is something that has to be mentioned. And at last, we also wanted to say that several of these options were addressing different sizes of problem. So they were also analyzing the scalability for the same heuristics and the same resolution process. They were trying to find, okay, how is this behaving when it comes to tackling different or a bigger number of customers? At last, when it comes to limitations, and this is something that is not included in this table, we found that the most considered constraints are the drone range and its payload. And this is usually a common question when I'm giving these kind of conferences. How much is capable the drone to carry? What about his autonomy, etc.? However, we found some gaps still while considering all these different papers. For example, very few of them consider charging cycles or the computational complexity, also the time constraints for calculation, or sometimes they just overlook the daily issues that may arise in this kind of situation. But on the other side, we found that every day we are trying to tackle more real life alike problems. So we are in the direction. However, we could finish this chapter of literature analysis saying that the literature is showing a field in flux, rapidly adapting to technological advancements, but also facing a set of persistent evolving challenges. Then we come to the discussion of the results. What can we conclude from this? Well, we can say that while the diversity in problem formulations and solution methods demonstrates the field richness, it also exposes a lack of standardization. Varying scales and scopes of studies indicate that the academic community is grappling with the balance between computational tractability and real-world applicability. The disparate treatment of limitations across studies suggests that there is room for more holistic models that account for real-world constraints. And at last, we can say that this fragmentation implies a need for unified frameworks that can synergize these diverse research efforts, therefore providing a more comprehensive understanding and solution for last-mile logistic challenges. Final point, conclusions and future research. Well, we must say that right now there is a considerable fragmentation in problem formulations, heuristics, and real-world applicability considerations, and that the emerging nature of the field highlights the need for harmonizing these diverse research efforts. And when it comes to future research to address the identified gaps, we will mention 3 different points. A, the development of unified frameworks that can integrate various problem types. B, explicitly addressing real-world constraints, such as regulatory requirements and drone charging cycles, to improve the operational viability. And C, a pressing need for benchmark datasets that can serve as a common ground for assessing the effectiveness and efficiency of various heuristic methods, thereby facilitating the comparison and evolution of solution approaches. Here you can find the list of references that were used for this conference, and this was everything. So please, if you have any further question, feel free to make it here or to add me in LinkedIn. In this case, my LinkedIn is David Sanchez Wells, so there you can connect with me and you can make any question in respect of this topic to me. So thanks a lot for assisting to this conference and see you in the next time.